Hello, my name is Patrick. I work for Blue Robotics, a company that develops ROVs, remote operated vehicles, as the Blue Bolt, unmanned surface vehicle. The company also provides the building, or like the basic foundation for developing other vehicles, and it's pretty popular. My idea here to talk about MAVLink tools, so some of the tools that we use, that are the base for mostly for software development. And the subtitle is Tomorrow's Solutions for Today's Problems, because I see that some people are using, but I believe that some use case, the use case that we're seeing here, could leverage the tools that we use and can collaborate with us for further development. So one of the phrases that fits really well here is that the people who have the greatest impact in the world are annoyed when they get stuck doing boring chores that could be handled more efficiently. And that resumes pretty well most of the tools that I'm going to talk about. In the past, we were using Companion. It was a fork of the Autopilot old Companion software. It was a monolithic node-based software. It provides a really basic abstraction for the user to command line interfaces. At the time, it was MAVLink proxy and the JStreamer command line too. And for a user experience, we had a lot of problems. First is that a user needs to have technical background to configure MAVLink endpoints, and also technical background to deal with camera pipelines. And this is pretty complex. If someone deals with the JStreamer pipelines, no, that's not an easy task. You need to know somehow what you're doing, and there are some magic things that you need to know and be aware about when creating pipeline. Otherwise, the user can have a really poor glass-to-glass latency between the camera feed and his computer or ground control station. In the case of IHV, a remote operated vehicle, you have a tether that connects your surface computer with the vehicle, and you have directly internet link. So we have this directly internet link that provides the MAVLink data as well the camera feedback. And as you can see here, we have the MAVLink proxy configuration and also the camera setup, where the user can change the JStreamer pipeline, and also the video for Linux controls that are available via the video for Linux interface. And at the time when doing development, we thought that it was kind of hard doing development based on these and using these tools. So we tried to create something new. And that's what I'm going to talk about. One of the first tools that I'm going to talk is MAVLink Camera Manager. It's already 4 years old, a really small child. It replaced hard-coded JStreamer and FFmpeg pipelines with friendly interfaces. It was in the final era of our old Companion software. We are already starting to use it, and we started to adopt. So it provides a REST API with stream management, thumbnail generation, and also camera control. Camera control, at the moment, it just supports video for Linux, but our target is to support also on-viv controls for IP camera-based systems. In the case of ROV, usually have like more than one camera. So supporting IP cameras, multiple IP cameras on the same network is kind of a requirement, and really good thing to have. Something really cool that also provides is WebRTC support. And this allows you to have a really small glass-to-glass latency to web technologies. And as an example, you can create a web-based ground control station if you wish to, because you can have this video feed quite easily. As I said, IP camera support multiple and different streams. I'm going to talk about that further. And also automatic vehicle setup. This is really cool, because if a user or someone that is dealing with the command line interface of the camera manager wants to support a specific vehicle, not necessarily the Blue Bolt or the Blue ROV, you can configure the system to automatically generate the necessary video streams for this specific vehicle. And for companies or people that just have their own vehicles, they can easily add this really small flag that specifies the vehicle name, and the camera manager automatically deals everything with the camera stream pipelines for you. This is the GitHub page. As you can see, we have plus 90 stars. This explains a bit more with what the project does. As I said, full REST API. As showed yesterday, we also have a full Swagger documentation of our entire API as well. For developers and users that want to take a look on all possible functionalities, they can go there and take a look. Also, there is SDP files for people that just want to use third-party video software like VLC. They can just have as argument the SDP file or SDP source. And with that, you can have the video stream play in your ground control station, your VLC, or any software that you wish to. We also have support to the MAVLink camera standard, where you can easily connect with key ground control or other ground control stations that support the MAVLink camera standards. Here is a really simple example of the interface. The development interface is not the final user interface. But the really cool thing here is that you can just run it right now in your Linux computer. If you have JStreamer installed, it should be ready to fly. As I forgot to say, we also provide binaries for our architectures, ARM 32 bits, ARM 64 bits, Windows, Linux, and Mac, x86, and ARM. Windows and Mac doesn't have support to JStreamer pipelines, but can work with head direct video streams. So you have IP camera, you can head direct your video stream through the camera manager and make it able to work with a ground control station. And I was saying, the development interface is quite simple. You have all this data that you can configure video streams and also watch your video stream directly there via the WebRTC source. But this is just a development interface. It's ready to use, go, and that, no problem. But nothing's holding you to develop a really nice interface where users can interact with it quite easily, like having checkbox to enable thermal and disable, like enable and disable thermal cameras, configuring UDP or different types of RTSP streams. One of the clients that we had, he had problems having RTSP, and we added support to multiple different RTSP types, in the case that UDP, TCP may not be working quite well on the network environment. And of course, it's a really nicer way to configure and deal with your camera stream. And the camera manager is quite complex. This diagram explains a little bit what it does. Well, it's JStreamer based, it's ready to use binary, except you need JStreamer DLLs. We're not providing it. You can install via your operating system manager. Is integrated with control stations. It follows MAVLink camera protocol specification. One thing that we try to do as much as possible is to avoid transcoding. We put a lot of time on the JStreamer pipelines that we use, because if you try to do video transcoding the media, you increase this glass-to-glass latency. And we try to decrease it as much as possible for user feedback and control on the vehicle. We try to target around 125, 150 milliseconds between the camera and the surface computer. And we also get really good times through WebRTC as well. The latency that we add through the camera manager is really small. The software is good, and to me personally, is the best video stream software for, like, if you have a Linux computer. If you're not using MAVLink, it's still great. But we also, like, it was done to firstly to support MAVLink and deal with the key ground control at the time. And things that we're working on is video recording on the vehicle side. This is important because sometimes you are flying a vehicle or you're piloting an ROV and the connection may break in the middle. So for that, we are trying to record the video locally or recording chunks. So if you are also recording the video in your surface computer or your ground control station, you can also recover chunks that you are losing and recover the entire video stream on both ways. You can have the video stream saved on the vehicle side, or also recover specific frames on the on the surface computer. Audio transmission is something that we are working on as well. We think about subtitle generation for on-screen display and integration with a pub/sub architecture for people that are using RAWs or something else to just easily take average of it and have the video feed directly from like a RAWs node over integrating with a UDP source if you wish to. And well, multiple APIs, command line interface, REST, MAVLink, SDP. We have inputs via USB cameras, CSI cameras, RTSP, all with. We are working heavily on H265 because of the bandwidth issues that people may have. And of course, for outputs, we have UDP, RTSP, WebATC, and also thumbnail generation if someone wants to take snapshots. The other project that I want to talk, before, let's just showing up really quick. So here I have camera manager working through BlueOS. As you can see, I have snapshots here on the real camera, and you can just go here and configure the video stream and change the brightness or change the contrast of the video stars, like quite easily for controls configuration. And of course, I can come here, modify or create and add, like change the size, frame rate, UDP, ATSP types, we put different endpoint formats. And this is a really simple interface that you create for the user. And of course, if we enable part mode, something really cool that we have in BlueOS that you can just enable full power of it, you of course can configure different PSM 2535, 2035 here on the Raspberry Pi 5 that I'm running locally here. And of course, creating fake video source for video development and much more. It's quite complete. Moving on. The other project that I want to talk about is MAVLink to REST. It's a project that I started 5 years ago with the idea to empower web technologies on the ground control, like for drone in the drone industry. I was really happy 4 years ago because I got it working, like the REST API was working. At the time, I have not completed the WebSocket functionality, but I remember that posting that really happy on the Autopilot forum talking, hey, I have this really nice tool that can use for people to just integrate web technologies with drones directly. And it was really exciting at the time. It was the basic foundation for BlueOS and our development on web technologies that integrate with the vehicle side. It has almost the same number of stars. It supports all operating systems. And it provides multiple functionalities as complete REST API for every single message that you can see there from the MAVLink standard, and also WebRTC, where you can see in real time the MAVLink message. It's not raw MAVLink message, but JSON-based MAVLink message, where you can easily integrate with JavaScript or any language as Python. So sometimes I'm doing development, I'm just open Python and connecting the WebSocket. If featuring the messages, I like maps. Or much nicer, you can also use WebSocket and JKey to filter the message directly on a terminal. So if you want to investigate and debug MAVLink message, you can do directly on the terminal without writing a single line of program. To a small demonstration layer. It's a critical service. It's a service that was like it's the basic foundation for everything that we do. Starting in the mid-2019, is a MAVLink, as I said, MAVLink serializer, deserializer for JSON 5. It's not JSON, it's JSON 5. The difference is that JSON 5 is a overset of JSON where it supports comments, it supports undefined values and other cool things. It's really interesting because you can just have extra functionality over JSON. The idea is to empower web technologies to interface easily with vehicles, provides RESTful API and WebSockets interfaces. You can friendly access message values and fields. As I said, you can have every single message, MAVLink message as a REST API. So you can do like dash MAVLink, dash heartbeat, dash like system ID, and you can have the value there ready for you without dealing with MAVLink at all. So everything available via REST API. And of course, you can have WebSockets filtering by message names. So if you create a WebSocket, but you want you just care about the heartbeat message or just care about the attitude message, you can pass it as a query parameters. And it's a reject. So you can also do some fancy things with it if you wish. It provides a basic front end with status visualization of the message, the frequency, the last message time, and of course, to visualize the message, and delivers a TypeScript definition of MAVLink message. So besides MAVLink to REST to exist, it also provides a TypeScript library where people can average MAVLink to REST in a safe way, where all types in all MAVLink messages are defined in TypeScript. And this ensures that every single access to the MAVLink message are defined through the TypeScript definitions, making the code development safe. So if we're trying to access a field that doesn't exist on a specific MAVLink message, the software will say, well, there's something wrong here because this parameter or this property doesn't exist in this message. And this makes the development really secure. And in the diagram, you have direct connection with the vehicle. You have also the history of every single message received, the last message. And with that, you connect directly with the REST API. So every single message received have a history, and you can take a look on it and see the message that received. And with that, you have the web server that creates a WebSocket connection directly to the vehicle. So when you have the WebSocket, is WebSocket vehicle, and you can communicate directly with it. The message that you're receiving or sending are just abstraction over JSON. So if you want to send a heartbeat, if you want to receive a specific message, you are directly talking with the vehicle with MAVLink to REST to be the man in the middle that translates JSON to MAVLink, MAVLink to JSON. And this is really cool because it empowers web technologies in a really fancy way. In this case, you have Node-RED. Node-RED is a block-based programming language that people can just drag and drop blocks and program really small JavaScript. And in this specific case, they are using MAVLink to REST to receive MAVLink data. And also it's connecting through serial port to a solar panel. And it's getting data from MAVLink to REST. It's getting data from the solar panel. They are saving both together a CSV file, also getting the data from the solar panel and injecting it to the MAVLink feed through Node-RED and MAVLink to REST. And simultaneously is also creating a dashboard for data visualization. Since the solar panel data is also being put on MAVLink to REST through the MAVLink message, you can easily see that in the UAV log viewer, where you can see everything integrated. So this user, he didn't need to to program something really fancy. He just dropped some blocks, connected it, take a look on the API, and was able to accomplish this really interesting tool where they can investigate and see what's going on with their boat. It's a really cool example of the power of MAVLink to REST. Another one is BlueOS itself. We have the heartbeat icon to be sure that the connection is available. You can access parameters quite easily through the parameter protocol. You can fetch information from the flight controller. And well, everything that can be done through MAVLink can be done via web technologies as well with MAVLink to REST. The difference here is how you're going to do it and how much time you're going to put on it to make it pretty. And that's really interesting. And of course, it's also possible to do web-based ground control stations. So in this example here in Cockpit, we're going to have a talk tomorrow about that. It was entirely based on MAVLink to REST to provide, to get and publish data via web technologies. And of course, getting data there from the video using the camera manager with WebRTC. And as talking, it's quite easy to arm and disarm a vehicle through MAVLink to REST. In this case, you have core with a request to post. And okay, my system ID is 255, my component ID is 240. And I'm just want to send a command long that type mav command component arm disarm, and I can just change it to 1 to 0 to arm and disarm the vehicle. And yes, it supports comments because it's JSON 5. So for a user, this is really cool because you can see the comment, you can copy and paste it, and the comment there is easier because the user know what this parameter does because there is a comment there. And since he's going to paste this command on the terminal, he will be able to see the vehicle arming, disarming. And of course, this consequence of it is the base mode bits changing from one to other. And to visualize it, you can use WebSocket and JKey. WebSocket just connects a socket and makes it available through the terminal. And JKey is a command that helps you to deal with the JSON. In this case, I'm selecting message type heartbeat with component ID and system ID of 1, and I'm printing the message. So just to show here example really quick. In this case, I can have WebSocket working here, and I'm printing, well, it's not showing very well, but trust me, it's printing the heartbeat. So it's printing the heartbeat. You can see the bits as 81. So if I try to do a curve post as arming the vehicle, you can see that the bits mode changed to 209. And of course, I can disarm again the vehicle. Oops, changing the parameter type to, oh my God, change the parameter type to 0. And the vehicle is disarmed. Really quickly, really easy, JSON, friendly, nothing to worry about. And of course, there is also the comment there. I'm posting the request with the comment. So like, I know what this parameter does because there is the description there. Okay. Saying that, 2 point, MAVLink TrueS and Camera Manager, they are not just development. Well, more than 4 years there. We have over 3,000 vehicles running BlueOS. Yep. And these vehicles are running the Camera Manager and MAVLink TrueS as the basic blocks for everything that we are doing. And we have over 170 daily users. So everything is quite fine. And based on our experience in development BlueOS and these tools, we also have another tool that we are creating based on everything that we learned. And this tool is the MAVLink Sava. We started this year during the company meetup. Is one broker to roll them all, and that's the description of it. Replaces MAVLink routers, MAV P2P, MAV proxy, and MAVLink router. But not only that, is multi-thread friendly. It provides an interface based in WebAssembly. It helps you with data visualization. It helps you with like easy integration with other drivers. It has a ready-to-use binary as all other softwares. So you can just download it now, run, connect through serial, UDP, TCP. You know, it's your choice. It is going to work. It supports the old connection like UDP source, UDP in, etc. as UDP out. The same command line to MAVLink router should work in place with MAVLink Sava. And of course, we also have a new way of doing it where you can just use specific parameters where you can filter specific system IDs, component IDs per connection link because of performance issues and other things that people can average and just do the best that they can do with the MAVLink Sava. It's based on the async Tokyo framework in Rust. It has statistics per message, per drive, bytes per second, how many, like everything that you wish to have the statistics. It's quite good because sometimes you need to debug MAVLink message and debug the MAVLink communication between the vehicle and the ground control station, and have this data is really interesting. And also allows you to add and remove drivers on the fly, different from MAV P2P, MAVLink router, if I'm not mistaken, MAV proxy. Not sure 100% about MAV proxy, but it provides a REST API where you can easily create and remove endpoints, MAVLink endpoints, without restarting the tool as a normal service or web service. And the idea is to have more things as rerun integration for MAVLink data visualization, and also like Lua integration, and everything is possible because of the software architecture. The software architecture is quite simple. This was work of João Antonio. He put a lot of time on this tool. João Antonio is maintaining most of these tools nowadays. And we are moving MAVLink to REST to MAVLink server because it's just another driver for MAVLink server. So at this point, we are working still on REST API and web frontend. Like we are working also on Tom for like custom description files of MAVLink endpoints, and also ARPL. We support UDP, TCP, file to log for read and write, serial, REST, WebSocket, and soon we are working to Zeno, Lua, and other drivers as well. Another interesting thing, we also have fake source. Fake source is like a MAVLink fake data source, so you don't need to have a vehicle to test a ground control station. You can just use a fake source to test your entire MAVLink pipeline and see how things are working, and see if you are losing message from one point to the other in the network when you have multiple MAVLink servers connected. And just to show here really quick, we can go on available services on BlueOS and take a look on the MAVLink server here. And let me see if I can make it better. Better. So as you can see here, you can have all the messages being received, all the statistics per message, number of bytes, delay, timestamps. And of course, if I want to take a look on the attitude of the vehicle, I can just take a look on the attitude message, right? And if I want to see the pitch or roll of the vehicle, I can just put the mouse over and have the pitch there quite easily, right? And not only that, it's real time, so I can move here my Raspberry and well, it works. Of course, every single message, every single value here that we are seeing is being plotted in real time, thanks to WebAssembly. Works really well. And the statistics here are per message. Of course, they are not connected because we have our own MAVLink parser that João Antonio put a lot of time on that to make it the fast and the best that we can. So we have the non-MAVLink message that you can see here based on the fields that we're plotting. But at the same time, we are aware that people can receive MAVLink messages that we may not support, or they are not documented, or they're in development. And with that, we can have also the statistics information on every single one of them here. And well, as you can see, it works. And that's all. I would like to do special thanks to Blue Robotics for being here, also our pilot to creating this really awesome event. The MAVLink, João Antonio for helping me with these tools and now being the maintainer of them, and also all the collaborators and contributors. And that's it. Questions?
Hi, thank you for the talk. It was really good. I'm going back to the camera manager. Apologies if you addressed this back then, but there are some cameras coming out like the Sony ILX, for example, that have their own SDK hooks. Is there a way to work with that using this camera manager at the moment?
Well, if it supports Linux, it should work out of the box. If you have a GeoStreamer like element, it should work. There is also the advantage of it's something that Camera Manager supports, to create our own custom GeoStreamer element that use the SDK and just take advantage of this element and have it working. But if it works out of the box on Linux, it should work out of the box on the Camera Manager as well.
Perfect. Yeah, that sounds great. Thank you.
Hi, thank you for a great talk. Great to see all the features that you have developed. I was curious about many things, but one thing I wanted to ask about was the MAVLink server. So that runs on the companion computer, but then it also connects up to your cloud, or?
So the MAVLink server is just a MAVLink broker or MAVLink router. So you can have it connecting like one MAVLink server to multiple other MAVLink servers in a network if you want to crash or just do a direct connection. For cloud integration, you can just have a single MAVLink server that sends the data there. Or if you want to broker on the cloud, you can just have another MAVLink server. It's just a bridge. It's your choice to use it when you, as you wish.
Okay. Yeah. Thank you.
I really love that MAVLink server. It's very interesting. The fake source, I mean, I'm assuming, but can it be just a standard bin log?
Yes, it can. At the moment we have tlog support. We don't have binlog, but this is just a matter of time. So what happens at the moment, at exactly this moment, when you have a tlog, it just parser as fast as it can. So, but the idea for us in the coming weeks is just fix that and having it playing in real time. I think it may already do it. It just be like a parameter when creating the tlog endpoint as source. But for binlogs, yes, it's totally doable. We use a fake source because sometimes we're doing development and we want to test creating MAVLink message as fast as we can, just to test the entire bandwidth or doing the connection between my computer and the IOV and seeing if the connection is good enough or if you're losing packages or something is happening. So it's just a way for testing MAVLink connections between network environments. It was based on the fake source of the JStreamer pipeline, and you can create like this ball moving, and you can just test your JStreamer pipeline. We did the same thing with MAVLink. We could just generate random MAVLink messages for you to test your MAVLink connection on the network environment and see if everything is working. And of course, with the data from every single message and endpoint, you can also visualize if something is going wrong.
Well, thank you for interesting presentation. And I have a question about the camera manager part. And we also do streaming through the mobile network. And almost every time we faced the bandwidth issue. And my question is there a feature to change the resolution or frame rate before the bandwidth getting worse?
Yes.
Or a issue to shut down the streaming?
So at the moment, you can change the video size, the resolution, and also the frame rate.
Yeah.
You can also do it, how can I say, you can also use different output types. As I said, your network may be having problems with like UDP, but TCP may be working better because of your network provider in mobile. We saw this happening. So depending of how you connect your video stream, you may fix these issues through like just tuning the RTSP connection.
Is this automatically changed?
No, not automatically changed.
Oh.
Because some things, it can be done. Like if people want to collaborate and help with that, can be totally done. We don't do it at the moment because of time. We are working on other stuff. And the possibility in the future is also to allow transcoding if the hardware has the possibility. So if you have an NVIDIA board and you can do transcoding in real time, the WebRTC stream can dynamically change the resolution. We are avoiding that because of the latency issues, and we are running a Raspberry Pi 3. Some products like we're still running Raspberry Pi 3. So the camera manager and MAVLink to rest, they need to be to have the best performance that they can to deal with this hardware that we're using.
Okay, thank you.
So one more question more about the camera manager. So what if you have, if we want to have our own signaling server, for example, if we don't want to display it through a web browser running on the companion a web server running on the companion computer, if I understand correctly.
So we have our own signaling implementation. The signaling also was developed from us. It's not like the problem with signaling in WebRTC is that every single person has their own signaling implementation. But we have the signaling client and server done. And if you want to develop your own like video visualization, WebRTC visualization, you can take a look on the camera manager because it's there. So if I come here and go directly on the camera manager and take a look on the new WebRTC site, add consumer, and also add a WebRTC session. Yeah, here the video is working. Hey, so you can just use this WebRTC signaling client that we have here. The implementation is there, is open source. You can just copy it and have it working.
Yeah. So yeah, because what would be interesting is to integrate it with, as I mentioned yesterday, with the media server like Janus to be able to distribute it. I mean, I guess that could also be a part of Blink server as well. But
Yeah, but you can also connect through UDP and others, not necessarily WebRTC. WebRTC is just a possibility. But of course, the signaling needed to take care of. And it's open source. If you want to change the signaling logic, you can add it. And you can add the Janus signaling if you wish to. It's like nothing is holding you to add that.
yeah, thank you.
Well, if that's all, thank you, everybody.